In this episode, we're going to connect automation work to the infrastructure it relies on, because deployable automation doesn't live in a vacuum. Even if your automation logic is perfect, it still runs in an environment made of networks, identities, permissions, compute, storage, and configurations. Infrastructure as code, often shortened to infrastructure as code, IaC, is the idea that you define that environment using code-like files that can be versioned, reviewed, and repeated. For beginners, the new challenge is that infrastructure is not just one thing you set up once. It's a pattern you want to repeat consistently across test, staging, and production. Reusability is how you make that repetition real without copying and pasting large chunks of configuration everywhere. When IaC is reusable, you can apply the same infrastructure patterns in many places with small, controlled differences. That keeps deployments predictable and reduces the risk that one environment quietly drifts into a different shape than the others. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Reusability in IaC means you can take a well-designed infrastructure pattern and use it again and again without rewriting it each time. A pattern might be something like a standard network layout, a consistent approach to identity and access, or a repeatable way to deploy a service with logging and monitoring. Beginners often approach infrastructure by building it once, then duplicating it for the next environment, which seems efficient at first but becomes expensive over time. Copying creates forks in your configuration, and those forks drift apart because each copy gets small edits that are not applied everywhere else. Eventually, you have environments that look similar on the surface but behave differently in ways that matter, such as having different permissions, different security rules, or different logging settings. That drift makes automation harder to deploy because what works in one environment may fail in another. Reusability is the antidote because it replaces duplication with a shared definition, so improvements can be applied consistently without manual synchronization across copies. A reusable IaC pattern usually starts with separating what stays the same from what needs to vary. The same parts are the stable design decisions, like the structure of a network, the shape of a service deployment, or the baseline security controls you want everywhere. The varying parts are the environment-specific values, like names, sizes, locations, or specific identifiers. When you design for reuse, you build a template-like pattern that accepts a set of inputs and produces a consistent set of infrastructure resources as outputs. You are not thinking about one environment. You are thinking about a class of environments. This is an important mindset shift for beginners because it moves you from building a one-off setup to building a repeatable capability. In automation work, repeatable capability is the goal because automation should behave consistently across environments, and consistent behavior depends on consistent infrastructure. Reusability also supports security by making secure defaults easier to spread. If your reusable pattern includes strong baseline controls, like least privilege access, encryption settings, logging, and network segmentation, then every environment built from that pattern inherits those controls. Beginners often struggle with security consistency because security settings are scattered across many infrastructure definitions, and it's easy to miss a spot. A reusable approach centralizes the pattern, which reduces the chance that someone creates a new environment and forgets a key control. In practical terms, reusability turns security into a default rather than an optional add-on. This matters because automation often runs with powerful permissions and touches sensitive systems. So infrastructure weaknesses can become automation failures or security incidents. A reusable IaC pattern can make safe behavior the natural outcome, not the result of constant vigilance. Another benefit of reusable IaC is readability and reviewability. When infrastructure is defined in many duplicated files, reviewers have to read the same structures repeatedly, and they may miss subtle differences that create risk. When infrastructure patterns are reusable, the core logic lives in one place, and reviewers can focus on changes to that pattern rather than scanning dozens of copies. This reduces review fatigue, which is a real risk in operational code bases. It also improves auditability, because you can point to a single standard pattern and demonstrate that it is used consistently across environments. For beginners, auditability might feel distant, but it becomes very real the first time you need to prove what was deployed and why. Reusable patterns provide a clear trail. You can trace environments back to a shared definition and specific input values, which makes infrastructure behavior easier to explain and verify. Reusability also helps with troubleshooting because it reduces the number of unique snowflakes you have to understand. A snowflake environment is one that is unique in ways nobody intended, usually due to manual tweaks or copied configurations that drifted. Snowflakes are dangerous because they break assumptions. If your automation is tested in one environment and deployed in another, and those environments are snowflakes, you cannot trust test results. With reusable IaC patterns, environments are more likely to be consistent, so test outcomes are more predictive. When an issue occurs, you can reason about it using the shared pattern and the specific values that differ, rather than guessing which hidden differences might exist. This makes incident response faster because you can narrow the investigation to known variation points. In automation, faster troubleshooting is important because failures can cascade and cause delays in broader workflows. A common beginner misunderstanding is to think that reusability means everything must be identical everywhere, but that's not the goal. The goal is controlled variation, meaning you know exactly what differs and why. For example, a production environment might have more capacity than a test environment, but the security model and network layout should still follow the same pattern. Controlled variation lets you scale and adjust while preserving the structural guarantees that keep automation predictable. Another misunderstanding is to treat reusability as an advanced optimization you do later. In reality, reusability is often easier to build at the start than to retrofit after many copies exist. Once duplication spreads, the cost of consolidating patterns increases, and teams often avoid that work until the pain becomes severe. For deployable automation, building reusable patterns early prevents that pain from accumulating, and it makes future scaling and expansion safer. Reusability in IaC also supports collaboration across distributed teams because it creates a shared vocabulary of infrastructure patterns. If everyone uses the same reusable components, people can discuss infrastructure decisions at the pattern level instead of arguing about local differences. This makes coordination easier because the team is aligned on a standard approach. It also supports onboarding, because a new contributor can learn the reusable patterns and then apply them consistently rather than learning a different configuration style in every environment. In automation work, where teams may frequently add new integrations or new environments, onboarding speed matters. A reusable pattern library becomes part of the team's operational knowledge, and it reduces the chance that new work introduces inconsistent infrastructure. Consistency is what keeps automation deployable as complexity grows. Another important angle is how reusability affects change management. When you update a reusable pattern, you are potentially updating many environments at once, which is powerful but must be handled responsibly. The key is to make changes deliberate, test them in a lower-risk environment, and then roll them out with clear understanding of impact. The advantage is that you can fix systemic issues and improve security across the board without touching each environment manually. The risk is that a mistake in a shared pattern could propagate widely. This is why versioning and careful review are important for reusable infrastructure components. Beginners should see the parallel to software libraries. A reusable infrastructure module is like a shared dependency. You gain consistency and speed, but you also take on responsibility to manage changes carefully so you do not break dependent environments. When managed well, this trade-off is strongly positive because it reduces long-term maintenance costs and improves reliability. To keep patterns consistent everywhere, reusability also benefits from conventions around how inputs are named and how outputs are exposed. If each environment passes inputs differently or expects outputs in different shapes, you lose the benefit of a shared pattern because the integration becomes inconsistent. Consistent inputs make patterns easier to consume, and consistent outputs make it easier for automation systems to connect to the infrastructure they need. For example, an automation workflow might need to know the endpoint of a service, the identifier of a resource, or the name of a role it can assume. If reusable patterns expose those values consistently, automation can be written in a more generic, portable way. This is a deeper form of deployability because it means automation can move between environments without being rewritten for each one. Reusability therefore supports not only infrastructure consistency, but also automation portability. To bring this together, IaC reusability is about creating repeatable infrastructure patterns that can be applied across environments with controlled variation. It reduces duplication, prevents configuration drift, and improves security by spreading safe defaults consistently. It makes review and auditing easier by centralizing core definitions, and it improves troubleshooting by reducing the number of unique environment shapes. It supports collaboration and onboarding by giving teams a shared library of patterns, and it supports predictable delivery by making infrastructure behavior consistent across test and production. For beginners, the key takeaway is that reliable automation depends on predictable infrastructure, and predictable infrastructure is easiest to achieve when you build it from reusable patterns instead of copied one-offs. When you understand and apply reusability, you create a foundation where environments stay aligned, changes are managed deliberately, and automation remains deployable wherever it needs to run.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.